Hello, hello. Um, Today we're gonna play a bit around with our algorithm here. I've decided that I have figured out how to modify the collision detection algorithm and implement what I want the collision detection slash resolution system to do. Um, since I don't have a lot of time today, um, I'll be uh, keeping the stream rather short. Um, yeah, but we will look into uh, yeah, we will be looking into the physics system where we will implement a bit more robust method for resolving these contacts. Right now, we just simply iterate over each contact for each what do you call it? Each contact for each collision. And the first part of the code is fine. We simply just want to do a bit more. And yeah, so we'll do that. Let's see, let's see. Uh, so yeah, we have our inertia calculation, which means how much effect we have to apply on the precision corrections for each kind of unit of movement that we want to move. Um, we start by calculating the relative position to the center of the object, and we use that um, offset to calculate uh, a vector that is uh, based on the cross product of the relative position of the contact point at the center of the object and the contact normal. Then we apply the translation or the transformation stored inside the inverse inertia tensor. And we cross that back to get a direction for the final amount of movement. We find out how much of that is along the contact normal. The linear inertia is simply related to how heavy the object is. Of course, the heavier the object, the more inertia it kind of has, and resistance to movement in general. So yeah, that's it. Right now we have added this position update, but we're gonna remove that. Let's see. We will store the angular inertia, and we will store, wait a minute, this is for each contact. Now, we're not gonna do that. We're just gonna continue on here, and let me remove that. Then we calculate the angular movement uh, um, as the penetration depth times, let's see, we actually also need a total inertia to get the respective relationship between the angular and the linear inertia. And then we set this to the angular inertia divided by the total inertia. And the linear movement is equal to also the penetration depths column for the collision, and then the linear inertia divided by the total inertia. Then we want to yeah, we could do some scaling of the whole thing. Uh, could clamp it. We could do some movement clamping. Uh, uh, if the angular movement is different from 0, we have some angular movement. We find the angular direction to be the body relative, the cross product between the relative position of between the contact point and the body center of mass and the contact normal of this collision. And we want to use the transformed inertia tensor to transform that position. And we set the angular change to be the angular direction transformed by the transformed inertia tensors for this object. And we store that. We create a linear change vector, which is simply set to our linear movement along the contact normal. So we specify the contact normals for this collision and the linear movement. Then we simply, instead of this, do something like this, where we take the position and we add wait a minute, this is something we already do. Yeah, so we move this. We don't need that. We also don't need that. Or do we? Maybe we do. And we have our physics quaternion here. Rotation, let's see. Ah, whoops. And we need to update that. It's basically a quaternion that we want to update by this angular change. Right now without any clamping of rotation needed. Let's move this down here. No. Let's do like this. Let's see, did we already do that? I think we did. When we did the integration of the objects here. We kinda... let's see. Yeah, wait a minute. Wait a minute. It's not the rotation, it's the orientation. Yeah, we actually implemented a method where we do it. Yeah. Not position, but orientation. But we update the orientation by a vector that is scaled by whatever value we want to store the angular change. And we simply want to scale by 1. All right. Let's test this out. Whoops. All right. Something immediately flew off the entire world. Let's see. That was totally not expected. But sometimes you get different surprises. Let's see. Now that looks a bit more reasonable. A bit more reasonable. Let's see. Does it pertain to? No, what? Well, it seems like something is kind of happening. Let's see. Anyway, doesn't it look a bit better than before, actually? I mean, notwithstanding the bug, and we might have a situation where we simply apply too much notation or something like that. Maybe the object just freaks out. Maybe it's related to the face normal. I mean, it simply just flies off whenever it collides with whatever that is. Let's see. So now we have a lot of vibration. We have an object that behaves entirely nothing like it should. For some reason, it simply flies off. Um, let's try to print the yeah, we might end up in a situation where we let's try to do this only for one contact. Let's see, we end up in a situation where we no, it doesn't seem like we end up in a awkward situation. So yeah, it's pertaining to the accumulation of different forces, probably when we do several contacts. If we do something like this, we have a subtle rotating effect since we're only applying position correction to 2 of the 4 detected contact points, and yeah, we already have a problem. So yeah. It's obviously related to the total amount of correctional force, or rather not force, but positioning, since it doesn't seem like we can provoke it even, or rather, oh, we can. Huh. Let's dump the angular movement. I know we will get 4 of them probably. Linear movement. We don't apply anything. That might also be a problem. Whoops. Nope. I'm just not doing this correctly. Let's see. Angular movement, nothing. A bit of linear movement. Seven units, I think. A very small amount and then a certain massive amount. Let's do a division by contact size, of course. Let's try that. We only do it once, so yeah, for some reason it really just flies off. It's actually no matter what I do, it seems. As long as we move it, we end up in that situation or what? Huh. It implies a lot of movement even though. How come? Hmm. Maybe we initialize it at 0. Let's just do that. Let's just try applying the linear movement here. Yeah, it may pertain to the angular movement here. Yeah, it seems like if I disable it again, we do have the problem of the object disappearing, which is interesting, but really not what we're looking for. So the angular change. Nothing changed. No, it's ang changed, of course. Let's see. Flies off. Angular movement. It only applies a lot of linear movement. Did I make a mistake somewhere? Let's see what happens if I it gets extremely high. Well, okay. I don't know. So it seems like this is before the and we do get several contact points for some odd reason. The angular movement gets really affected. Let's just print a new line, a couple of new lines here. It seems like it bounces all over and gets a million contacts. I mean, this contact generation here is amazingly weird. I think the angular movement kind of affects the whole thing, and you end up in a situation where you have too much angular movement. So let's try to do some clamping on the rotation. So we do a calculation here where we do a float projection, which is math. Let's see. Yeah, we could do. Yeah, it would be easier to do something like projection matrix. Scale vector. We take the body relative contact position. We add the contact normal. And we scale it by the negative dot product of the, or rather, no, or rather, yeah, I think, yeah, the relative position and the contact normal for this collision. That is our projection alongside the contact normal. And we add that to the contact point relative to the center of the object. And then we calculate a max magnitude which is equal to sine, maybe some amount here where we do math, or rather square roots of math dot product of the projection, meaning that let's see. Yeah, maybe we don't need the casting. If the angular movement is below the negative max magnitude, we correct it. Let's see, not real. The and the linear movement is going to be set equal to the total move minus the angular movement. And we of course do the same if we have an angular movement that is greater than that. Yeah. Let's see. And then we might actually also have an error here. Yeah, I think so. There's an error here, which might also add to the problem. Not only do we want to affect this, we want to set the angular change to a scalar version of this, meaning that we put in the angular change and we scale it by the angular movement divided by the angular inertia. Let's see. Let's see. No weirdness thus far, and we have everything enabled. Yeah, it was obviously a mistake in terms of this never got scaled, so we just applied the raw vector. If I disable the clamping here, will we then get weird behavior? Let's see. The primary problem was that we didn't scale the actual rotation. This seems a bit volatile. As you can see, we can get some really serious rotations, but if we disable that, or rather disable the clamping, uh, all right. And how does it translate? Well, it just ends up hanging there. Right now, all the forces are kind of disabled. Since we reset the velocity every frame. Let's see, let's disable this slow printing. No need to do that. Yeah, and let's try disabling the disable the disablement of the physics. Yeah, we definitely do not handle resting contacts that well right now, but yeah. Um, yeah, but the physics part of the, or rather the um, velocity adjustment of the collisions are still lacking. Yeah, but at least the system is not totally unstable. But it definitely works better when the physics isn't implemented. In terms of the velocity manipulation, it does look funny though. it just sinks slowly, and if I interact with it, okay, that didn't look super great. Anyway, we definitely need a more robust system. Right now we can handle interpenetration. Yeah. You can see the player collider here trying to intersect but getting shoved off. Yeah, I will redo the collision detection algorithm and the do a bit of more work on the contact generation algorithm as well. So yeah, the system might get more stable. We might implement a part of the velocity regulating part of the collision resolver method in the next episode. But yeah, I think this part of the collision resolution system is not 100% done. We still, I mean, it's only the position handle correction that is going on right now. We have no calculations of correctional movements or anything, and we definitely do not have any contact force uh, any contact force handling. Yeah, I think that is almost it. Yeah. Yeah. We of course need an iterative solver and everything in terms of handling actual collisions, but this is part of a manipulation of the position. I think that is it. Maybe we want to experiment with yeah. So at least the interpenetration is handled correctly. We could disable all the all parts of the algorithm for now. Maybe except for this part. Um, yeah. Yeah. I actually think that is it. For today at least. Mm, yeah, once we have the system up and running with an iterative solver, um, I think we should play around with some different values in terms of mass and test out different forces. I mean, let me just try something. What if I hurry up and try to... I think when it gets to the other side, it simply just falls through, because the floor is so slim that you end up with a face collision that is actually on the opposite side of... I'm sorry. You probably end up with a entirely different contact normal. Yeah, as you can see here, the contact normal is actually going downwards, meaning that it kind of shoots the object in the in a different trajectory. Yeah, so it's not because... Yeah, we also need some correctional force at least, or a force absorption whenever two objects collide. Right now, we don't have any force absorption, meaning that we rely on the repositioning of the physics system to handle collisions, and that's not enough, especially when I apply force, which is what I do whenever I shoot the object. You can of course see that I actually shoot the object with rays right now, but that's what I'm doing when the object is moving around weirdly. So right now we simply reset for each contact. Even we could do this. We don't need to do it for every contact. We could simply do it here. And change the velocity. So right now we do not have any gravity. Actually, I do want to test one last thing for today. It's not during our onCreate, it is during our thingy here. Okay, so 4 and 5 does something. Let's see, inside the player controller, is it there or is it somewhere else? Is it inside the player controller? No, it's not. I don't think so. It only handles movement, right? Yeah, it should be. Well, did I just miss it? Has been. Oh, it's right here. I just haven't commented it. EG. R key. And the force should probably... Um, there we go. We reduced the force. Yeah, okay. Um, let's not offset it that much. Move it back in. So I can interact a bit with it. Okay. Let's see. Okay. This is definitely not working super great. So maybe if we add a bit of updrift, it's the F5 key. It's definitely not much, but it's there. Okay. Yeah, we definitely need some correctional forces. What if I, excuse me, I don't know why I keep chewing stuff straight into the microphone. Let's just set the gravity to something really low. Yeah. And the updrift correctional force is probably enough to handle the gravity itself. Yeah, we should see some at least a bit of repositioning, but we might not be. Well, it does force the object out. Yeah, we definitely need some correctional force. Let's just swap to the character view here. Our ending scene. Alright, now we can't see anything. They may. We might just jump back to our. Did we just fall off the screen? I think so. Yeah, we're staring into blank, empty space. Okay. One last fun little mission for our guy. I hit him. Yeah, well, the gravity isn't great, but he should start falling a bit. Can't seem to hit the top of the box. All right. We have impact. He's just standing there saying hello to the world. And thanks for dropping by. See you hopefully in the next episode. Bye bye. Huh? Okay. Bye bye.